So welcome everyone, I'm Bruno. I just did pass from HackSmarter. That's an Active Directory box rated as medium. I think it's somewhere between easy and medium, but that's always subjective. There's no initial credentials for this box, so I started by doing some NMAP scans, and I found an SMB shared folder. And that gave me a list of 4 computers on the network. And also we had guest accounts. We can list shares with a guest account. And that allowed me to execute read brute force. That gave me some two users and 4 computer accounts and the respective reads. With the reads, I did a Timeroast attack and was able to get the hashes for the computer accounts, and I did crack one of the hash and get the password for one of the machine accounts. And from there, that particular machine had read permission on another share, on another SMB share that had a file with user credentials. Unfortunately, the user credentials didn't work so well because the account had a restriction, so I could not log in with the password, but I bypassed that by requesting a TGT ticket and authenticate via Kerberos instead. So then I used BloodHound to enumerate the server and found out that that particular user that I had the credentials, that he had GenericAll permission on the target machine. So from there, I did a Resource-Based Constrained Delegation attack that allowed me to get the hash for the administrator of the machine. From there, I just log on with WinRm, got the root flag, and then the last step for this box is to get the password for another user, and I found that password on the history file of the user, and that's it. That's a good learning box and a fun box. So let me show you how I did it, and come with me. So let's get started. Let me open the terminal, increase the font for you guys to see better. I'm going to create a folder for the box. Screen. And now we are going to start our enumeration by doing some NMAP scans. So let's use sudo because we need the raw socket access. NMAP -p to scan all ports, -P n to assume the host is up and avoid host discovery with pings. Then we only care for open ports. And we'll save the output to a file with a normal format called open ports and the name of the box. And now we need the IP of the box. Let's get to the HackSmarter website, copy the IP, get back to the terminal and paste it. And let's start the scan. Actually, this can take a while. I didn't specify any minimum rate on purpose because sometimes it misses some open ports. So let me fast forward to the end of the scan. So okay, the scan is over. We have a bunch of open ports here, and we need a list of those ports. So let me first clear the screen and check if the file it's okay. Okay, so now I'm going to need a list of all of these ports. All the ports start with the numbers and then a /. So let me get this file, grab all the lines that start with a digit. That will give us all the lines for the open ports, and then we'll use cut with the delimiter / and grab the first field. So let me see. Yes, we have the list of the ports, but we need this all in one line and separated by commas. So let's transform the new lines into comma. That's it, and we have the last one that we can retrieve with sed. Let's search for that last comma, so comma and $, and replace it with nothing. And now we have a list of all the ports separated by commas. Can copy this, and let me clear the screen. And now we can scan only those open ports to get more information. So let's use sudo, because we need sudo for the OS detection, NMAP -p to scan these ports. Then we'll paste the ports. And what else we need? We're going to avoid pings, and let's specify aggressive scan with the -A. This will give us OS detection, version scanning, and script scanning, and trace route. And let's save the file also in the normal format with the name ports info, the name of the box, and the IP of the box, which is then, I don't remember. Copy, get back and paste it. Let's insert my password and let it run. So once more, I will fast forward to the end of the scan. So it's done. Let's check the results. So we have port 53, which is DNS, 88, which is Kerberos authentication. That's the primary authentication protocol in Active Directory. 135 RPC, 139, that's SMB, 389 LDAP, 445, also SMB, 464, that's the Kerberos password change service, I think. Also, yeah. 593, it's an RPC over HTTP endpoint mapper. 636, that's LDAP over SSL, TLS. 3268, it's the LDAP. And we have here a domain, past.local. 3269, it's also, I think it's typical LDAP over SSL, I think. 3389, it's RDP, remote desktop, and we have a lot of info here. So we have NTLM info, have the domain name, computer name, domain, DNS computer name, have the common name for the certificate. And next we have 5985, which is WinRm. That's good for us. 9389. I think this one, I have to check my notes real quick. So, okay, that's the AD web service used by tools in PowerShell modules. Then we have 47001, which is also WinRm. And we have all of these ports here that are generally dynamic RPC ports after the initial negotiation on port 135. So we don't care much for these ones right now. Let's move on. We have Windows 2016, Windows Server. Now for the host script results, we have SMB host discovery, the computer name, domain name. We have this fully qualified domain name here that I'm going to start by copying this because we are going to need it. And account used guest. So I think we have guest. We can connect to SMB with the guest account and nothing more. So let me clear the screen. We have some good information here. Let's start by adding the etc host file. Sudo vim etc hosts. Now we need the IP that I already forgot, but let me paste the fully qualified domain name, and now let me check the IP really quick again, copy. Hopefully this is going to be the last time I do this. Paste it, tab, and let's put another one here like past.local to be simpler. Okay, let's save and quit. And now we can start our enumeration. Let's clear the screen. So let's check if we can access the SMB shares without credentials. NXC SMB past.local. Let's use user without anything, and let's list the shares. So let me explain what I'm doing here. I'm using a netexec with this nxc command with the SMB protocol. Let me open here the wiki. I think it's netexec.wiki. Yeah, that's it. So I'm using here, I'm using the netexec with the SMB protocol, and I'm looking for enumeration. And here we should have enumerate no sessions or something like here. Enumerate no sessions. So this is the commands I'm using. Because sometimes we can enumerate shares like this or users if we have anonymous access to the SMB. I don't think we have, because otherwise the NMAP would have shown that, but let's try it. No, access is denied. But we know that we can access the guest account. So we can put here guest or something else, you know, letter or dot, something like you can see that here. Enumerate guest logon. They put an A here, but it could be something. Let me try this one. So it's confirmed. You can log on with a guest account. And we have shares. SMB shares available to read. And we have these ones here. And the sysvol are common. This one, it's not a common share. And we have read access. So maybe that's the first thing to try. Let's use SMB client. And we need this. We need to access past.local and the share. And let's give it the user dot without a password. So usually this is username and password, separated by this percentage sign. But we don't have a password, we don't have a username. We could, yeah, it's the same, something. Because it's going to authenticate with the guest account. So let me see. Let's list the share. And we get this admachine.txt file. Let's get the file. And exit. Clear the screen, get the file. And we have this seems to be computer names or machine names. As this one here is the machine we are targeting. And then we have app dev01, web dev01 and dev01, which I'm assuming are other machines on the network. So we have found that there are other machines on the environments, but what can I do with that information? I can't think of anything right now. Well, okay, let's move on. So what can we do? We can try to enumerate users. Let me get back this command and put users here. Let's see if we can enumerate any users. We don't. Okay. You can try to with brute force. So you can try to enumerate users by brute forcing the reads. And yes, it's working. Okay, that's good. So all of these reads here below 1000 are system accounts. We don't care too much about these ones. But these ones here are user accounts. Or, because we have a few here ending up with a $, these are not user accounts. These are machine accounts or computer accounts. They are not regular user accounts. So we have Tyler, then we have a machine. This one and this one, I don't care about these ones. We have another machine, another machine, another machine. and then we have Ryan. Okay, so we have 2 users, Tyler and Ryan, and then we have 4 machine accounts. Okay, so in Active Directory, every computer joined to the domain, being a server, workstation, or whatever, gets its own AD account. And the Microsoft convention to name these accounts are the computer's host name with a trailing $sign appended. We have a list of machines linked in the SMB share. Now we have this machines account here, which are the same. That could not be just a coincidence. There must be an attack vector here somehow. So let me check my notes real quick. Okay, we can try a Timeroast attack. Since we already have the reads for those accounts, it will be quick and not too noisy. So let me explain this. Timeroast abuses NTP authentication. The domain controller will compute a MAC over NTP response, over the NTP response, using the requesting computer accounts NTLM hash as the key. So maybe we can grab some hashes for these 4 machine accounts. Typically, they are very good passwords, almost impossible to crack, but sometimes, I don't know, it all points for this attack vector, so we can try it. But we also need the UDP port 123 open for that. Let me check that really quick. So let's clear the screen. Sudo nmap -su to do a UDP scan on port 123. And now we can specify best.local. And it's open. Okay, so maybe you can retrieve some hashes and try to crack the passwords offline. All this points to this attack vector. Let me give it a try. We can use a module Timeroast, I think. Let me check. This will list all the modules for this protocol, SMB. Let's grab Timeroast. Yes. So you can try to use this module, but I think it's going to take quite a while, because I don't think we have any way of passing the reads that we already know. Let me check here real quick. Yeah, I don't think we have any options to specify the reads. But we have another way of doing this. I'm going to use this tool that I have here already installed. Timeroast and time. That's a Python script. I'm going to leave the link in the description if you don't have this installed, because it's not installed in Kali by default. And let me check how to use this. This one. So you can give it a comma-separated list of reads to try. Okay, so clear the screen. Let's specify this. And the reads have to go back. So the reads are 1009 for this computer account here. This one is 1115, 1116 and 1117. 9, 15, 16 and 17. So 1009, 1115, 1116 and 1117. And you have to specify is the domain. And let's save this into a file, ntp hashes.txt. Okay, so we have 4 hashes for those accounts. Now we can try to crack these hashes. I'm going to copy this first string here, this selection, go to the browser and hashcat examples. This one. Let me increase the font for you guys to see a little bit better. Let me Control F to find, paste that string, and yes, we have this hashcat module 31300 31300. So let's use this and let's crack the passwords, the hashes. Hashcat the module 31300, specify the file. Now I'm going to use user share word list roq. Let's pass the username --username, and since I am on a virtual machine, I'll use the --force flag, and let's try it. Oh, we already have a finding here. Let it run for the other ones. And we have a password here. I don't know which one is this one, so let me use the, what is it called, show. Okay, so we have the read here, 1115. Let me go up and see 1115, it's the app dev01 account. So let's copy this. And let's confirm. Let me clear the screen. And let's see if it works. So smb pass.local, the username it's going to be this account, and the password, oh, I forgot the password. Okay, this one. Password, and let's see. And yeah, it works. So we have a password for this machine account. And what can we do with this? We can try, because now we have credentials. The earlier enumeration that we were doing was using a guest account, and that gave us nothing. But now we can try to enumerate further. Let's begin with the shares. It should be the same as the guest account, I think. But let's see. No. You can read the net logon, you can read the sysvol. Okay, so, and we can go take a look on these shares, or you can try also to list the users. Okay, let me do the users export, because I think it's going to work, and users.txt. So this will display if it will find some users, it will display the users on the screen and also save it on this file users.txt. Let's see. Okay, yes. Now we have a list. We are going to have a list of users. Okay, it's just Tyler and Ryan. We already knew that. So note that in this command, netexec excludes machine accounts. That's why they don't show up on these results. The user enumeration here is different from the read brute force that we have used before. So let's move on. Okay, we have credentials. We can connect to the machine, so we can fire up BloodHound and try and enumerate the box with BloodHound. Let's do that. Let's do BloodHound Python. Let's collect all. The domain is pass.local. The username is $@dev01$. Sorry, $. The password is I think it's this one, right? Yeah, password. And now, what else? I think this, let me check my notes. Yes, this tool here requires the IP, which I can remember, so I have to copy it, paste it, and now let's instruct the command to zip the file, and let's go. It's working, that's good. Connecting to LDAP. Okay, one domain, 4 computers, it's working, 7 users. Okay, that's good. It's really good. Come on. Okay, and we are done. Let me ls. Now we have this zip file with all the information to the BloodHound. Go start BloodHound, a new terminal, and let's start BloodHound. You can start BloodHound depending on your installation. Mine is like this, but depending on the version that you are using could be different. But whatever, just start BloodHound and then, so okay, it started. Now let me open Firefox, local server, localhost, port 8080, UI login. I have to put the admin and the password, login. Let's choose the file, upload, 100%, close, explore this. Let's check for user Tyler that we know exists. Nope. Let's see, administrator, ingesting. So we have to wait a little bit. Analyzing. And now it's complete. So let's go to Explore. And now you can see Tyler. Yep. Let's click on Tyler and see what information we have here. I'm going straight to the outbound object control. It's always a good sign. Okay, so we have a GenericAll to our target machine. Okay. So the user Tyler has GenericAll permissions in our target machine. Let's click on GenericAll and see what can we do with this. The user Tyler has GenericAll permissions to the computer. This is also known as full control. This permission allows the trustee to manipulate the target object however they wish. So we really need to get into the Tyler account. Let's see the Linux abuse. Okay, we'll come back to this if needed. Now let's enumerate the server with BloodHound. So I have spent some time on BloodHound and found nothing. There must be another way of getting either Tyler's or Ryan's credentials. Okay, so let's focus. We have credentials for this machine account. We can list Oh, we already listed the shares earlier. We check that again. And we have these read permissions on all of these shares. So instead of using SMB client, I'm going to use in packet SMB client because it's easier to navigate between shares. So SMB client, the IP or the domain, I mean, now the account, the $01 and then should be colon and the password. And now I need to specify the IP at pass.local. I think it's like this. You clear the screen, enter. Okay, so you can list the shares. And you have all of these shares that use the first one at Logon. ls. Oh, we have this Tyler init command. Okay, let's grab this and exit. Let's get the file. Whoa! Oh my god, so easy. We have Tyler's password here. Oh. Okay. So easy. And I wasted all that time on BloodHound. Not sure why. Okay, so at least the shares, I didn't take a look at the shares and then I went straight to BloodHound. Because I thought Active Directory and should be the way, but maybe not. So I have this password. Oh, let's see if this password works. SMB user Tyler passwords. And let's see. Of course. Of course. Pass.local. Oh, okay, so you have a status account restriction. Oh, so the account may be restricted. Okay, so we are not able to authenticate with the password. Why do we have the password if you cannot use it? Is this a rabbit hole? Or can we use the password? Oh, maybe you can use the password or request a TGT ticket and authenticate via Kerberos with the TGT ticket, maybe? Okay, let's try it. We clear the screen. Let's use netexec, SMB, the same. Now you want to generate TGT and you have to specify a file name. Let's use Tyler.tgt. Fingers crossed. No. Okay, so it didn't work. We have the same restriction. Okay, maybe if we use another tool in packet at TGT and let's define this the domain, the user, column, the password, and the CIP pass.local. Okay, let's see. Oh, it worked. Saving ticket in this file. Let me see. So we have the file here. Okay, so now we have to export this file to the KRB5 CNAME, I think it is. I cannot remember. Okay, so let's use NXE SMB help grep for cache. Maybe Kerberos. I mean, I can do, I think it's E5. Okay, I think it's this one. Not sure. Okay, let me check my notes. Otherwise, I'm going to lose a lot of time here. Okay, export. Ccache, TGT, yeah, that's the one. Key RB5, CNAME. That's it. So, let me clear the screen. Export CNAME equals Tyler.ccache. And now, when I use nxc smb pass or log or user Tyler, I can use the flag -k to use Kerberos and -- use kcache, and this will use the Ccache file instead of the password. And now we can maybe have some shares. Come on, give me the shares, please, please, please. So I think it's authenticating. Oh, come on. This should bypass. Yes. Yes. So we have bypassed the password restriction. Nice. So Tyler have read access to all the shares and write access to the C share. Okay. Now, what can we do with this? Well, if we have the credentials for Tyler, and we saw already in the BloodHound analysis that Tyler has GenericAll over the target computer. So let's see the Linux abuse. Okay, so first an attacker does not control an account. It has to be set. A new attacker controlled computer account can be added. So we can add a computer account, and then we can delegate to that account. Then we have to get the service ticket. And with the ticket, we can impersonate a user. So this admin user could be impersonated. Okay, so let's try this. Let's try it. So I'm going to copy all this. Clear the screen, paste this, and okay, first of all, this is, let me check, in packets. So in Kali we have this in packets, add computer, remove the PI, yeah. Okay, so LDAPs, computer name, tax system, let's give it a shorter name, HTML, computer pass, could be this one, DC host, domain controller. Okay, for this one, I'm going to open a new terminal here real quick and get C hosts. I want this whole name here. Close this one, paste it here. Because sometimes he needs the fully qualified name here. Okay, domain netbios. This one, I think it's just the domain as local. Now domain as .local Tyler. And the password up, copy and paste it. So impacted add computer, the method ldapps computer is going to be a new computer, has to end with a $, a new password, the DC host, domain, netbios, pass local, and then domain, user, and password. Okay, let's go. Socket SSL warning error, connection reset by peer. Okay, so packet add computer help. Okay, so what do we have here? Domain method of adding the computer. Smart works over SMB. LDAPS has some certificate requirements and it isn't always available. So let me change this. Instead of LDAP, can use this one. Can use this one and what else? Let me check. Oh, you have this. You can use the Kerberos authentication and the no pass, because don't test password default for -key. Okay. So let's do that instead of these credentials here. You can pass the -k, something like that. I try it. The following arguments are required. Oh. I'm not using the pass. Okay, let's do it anyway. So let's pass the -k here at the end and let's skip this. It is supposed not to use the password. So connection reset by peer. Maybe this no pass. do the order matter, because here this is at the end. I don't know. Let me put it here. -k minus no pass. And let's try it like this. Connection reset by peer. Impacted that computer matter. Oh, I'm using the LDAPs. Okay. SMRM. Let's try it like this. Oh, it's taking time, and it worked. Successful added machine account with password. Oh, it worked. The thing is, I was using older commands in order not to type all of this, and I forgot to change the method from LDAPs to SAMR to use SMB. Okay, now we have a new machine account with this password. So now let's go to BloodHound and see the second step. Let's copy this. Back to the terminal, clear the terminal, paste this. This is impacted .api. So delegate from our new created account, delegate to this will be our computer account, which is this one. And we have to end it with a $sign. This is the machine account for our target. Action write, and now okay, so I'm guessing we are going to need all of this. All of this. Okay. So -k -no pass. What do we need more? Well, let's try it. Invalid server address. What? Yeah. Of course, I didn't provide any IP for the machine. So let's see. From earlier, we had this DC host. Let's copy this. Paste it. And try again. Oh, yeah. So, yeah. So accounts allowed. So delegation rights modified successfully. Our new account can now impersonate users on the target. Okay, so that's good. So let's go to BloodHound. The next step is to impersonate. Let's copy this. Paste that in. In packet. And now saves target compute no. Target computer is this one. Let me paste this here. Impersonate admin. We want to impersonate the administrator. And you want this. No? Oh, okay. You want the pass.local attacker system PML. PML. Yes, with the password. And that's it. Impersonating administrator. Error. KRP application error match ticket and authenticator doesn't match. Okay, so Kerberos session error. That means that ticket because the get_st, the packet get_st must be using that variable, that KRB5 CC name variable. I have to unset that variable. KRB5 CC name. Ctrl L to clear the screen. And let's try this again. And it worked. It worked, yeah. It worked. Saving ticket. We have a ticket for the administrator. Great. So now we have to export. Let me use this one. Export this variable to this new ticket. Okay. And now let's check if it works real quick. Use Kerberos authentication and then use Kcache. And let's list the sharers. So if this works, we should have all the shares with read and write permissions for the administrator of the machine. But it doesn't. Okay. Error. Timeout. Timeout. So this one, KRB5C name, minus you administrator, minus use Kcache and shares. I think this should work. Let me check. Let me check if this is running. It's running. Administrator. Well, let's try that again. Sometimes these commands fail at the first. Oh, yeah, it's working. So pond, meaning we can log in as an administrator, and now it should present us all the shares with read and write permissions. Yes. So we have read and write. Okay. So now we have credentials, Kerberos credentials for the administrator. Let's clear the screen. And we can connect, because on the NMAP scan, we saw that we had WinRm available. So we can use evil WinRm to connect. Let's pass the IP and the username. Let's connect with the administrator. And well, but we don't know. Evil WinRm needs either username or hashes. Okay, but we can use in packet secrets dump to get, well, use secrets dump to do a desync attack to retrieve the hashes of all users. So let's do it. So -k minus no pass pass.local. Let's use administrator at, I need a computer again. It is, okay, let's do it. Okay. So, secrets dump, use Kerberos authentication, no pass, the domain, the user, at the specific no, it's a dot. But I don't need all of this, I just need this. Let's do it. No. Maybe I need a computer. These impacted tools sometimes work in strange ways. So let me try this. Okay, now I think it's working. If this works, we should get the hashes for all users on the machine. And with the hash, we can connect via WinRm. Let me see. This is taking a while. I will fast forward to the end of the command. And it's done. So it took quite a while, but we have this administrator hash. You only care for the second part of the hash, so let me copy. Clear the screen, and now we can connect via evil WinRm, since we have WinRm available on this machine. So -I with the IP of the machine, the username, administrator, hash, and that's it. Let's go, fingers crossed. Okay, who am I? I'm administrator. Nice, so we are on documents. What do we have here? Nothing. Let's go and check the desktop flag. Desktop. Okay, we have the root flag here, so type root.txt, and now we have the root flag. Let's copy this. Okay. And let's try it here. Submit. Yes, it works. Okay. And now we need the Ryan's password. Ryan's password. Okay, Ryan's password. So you have to enumerate the machine. Okay, so let's see if there's some folder for the Ryan user. There is. Let's see what's in here. Okay, Microsoft desktop. Nothing. We have nothing here. We clear the screen. So we have nothing. We are administrator on the box. We can try to see the history for Ryan. Let me see. Type users. Users. Ryan. I don't know this by heart. I have to check. Okay, notes. Prevask. Windows. History file. And let me copy this. And paste it here. So it will be on user Ryan app data, local, Microsoft, blah 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 blah, console host history, and but not found. Okay. Oh, because this is for a local user. For a domain user, it's not local. It's roaming. Yes. Okay, so you have another password. Oh, okay, so let's maybe it's this one. Copy. Let me just. Okay, so this is the password, but let me choose because we are connected via evil WinRm. Let me put the password here and we'll check it in a minute. Let me show you another way. Let's get out of this one, clear the screen. Now imagine that we didn't have any way to connect via WinRm, RDP, or reverse shell, something like that. There's a module to get the history file from the netexec. I can't recall the name, so let's list all the modules for SMB. And here, PowerShell history. Extract PowerShell history for all users and looks for sensitive commands. Let's copy this. And pass.local. No, I mean, yes, pass.local. Username administrator. We have the hash, so I have to copy the hash. Then we'll specify this module. Let me grab the hash first. somewhere up here. So I need a hash here. Control, let me clear the screen, and the administrator, it's not right. Administrator, the hash, the module, and let me see if it works. So it connects. It's good. And yes, see, we have two. Oh, we have because it checks all history files for all users. We have the history file for Ryan, which have this password here, and you also have the history file for the administrator that has this password here, and it's the same. Sometimes when you have plenty users on the domain, you may want to export this listing to files. So you have an option on this module to export equals true. That will export all of this to local files on our local machine, a file per history file found. So PowerShell history written to, and we have here this file for the administrator and this file for Ryan. And it's the same. And now that I recall this module, yeah, this module is interesting because, let me show you. Let me show you like this. I think the box is done, but let me just show you something that could be useful in the future. So let me clear the screen. For this module, we can list the options for the module with the -- options. It states here that we have no options, but as we saw, we have an option to export. When you find yourself on this situation, what's happening here? The developer of this module didn't took the time to implement a command on the module that will serve as documentation, that will show up here instead of none. Let me show it. Let's find on the user folder with the name. Let's do this PowerShell history. Let's redirect this to the Null. Oh, of course, I forgot. This is a Python file. So here we have the file, the source code for this module. You can get this. Should be simpler. Okay. So options. We have this export that is going to be a Boolean. It's going to populate this export variable, and down here somewhere our file. Let's see here. If we have the export being true, so the boolean being true, so the module will write a PowerShell into our local list. Normally, the developer should put some comments here. Let me show you. Let's try to find. Okay, let's list here something to see another. Okay, let's use this one. Just to see if you have options. Yes, we do. So we have all these options for this module. And if let me find where the source code is. Empire. Here. Now here, see dev options, and then we have these comments here. The developer for the module PowerShell history didn't took the time to do this, so that's why we don't have any output when we list the options for the module. But the option is there. So -O to apply an option to the module, and export equals true. And I think we are done. Oh, we have to see if this works. Submit. Yes!